how can I proceed to show you my presentation?
Okay, yes. Do you see the bar on the
Yes, I see the bar.
inferior part of
More
the, okay, you
actions.
see the third icon from the left.
Yes.
Okay, you click on that icon and you will see a menu containing different options for sharing your screen, and you have to select
Full
the third
screen.
option,
Okay.
full screen,
Yes. Full
exactly.
screen. Okay.
Then you click on the preview of your screen, and then you confirm on the share button.
Okay. Good. To share.
Share, sorry.
I don't see it. Sorry. I'm searching it.
Okay, I'll show you. I'll share my screen to show you the procedure.
Okay. Thank you very much.
You're welcome. Okay. Can you see my screen, my
Yes,
monitor?
I see your screen. Yeah.
Okay.
Yes.
So you have
Okay.
to select
That
this
icon.
icon,
Okay.
and
Okay.
now I stop
Good.
the sharing. Okay, this is the
Okay.
icon. Then
Yes.
you should see a menu, and you
Yeah,
should see
I see
three
it.
options: Chrome,
Mhm.
window, and full screen. You have to select the full screen option. Then
Mhm.
you will see in the, okay, now we can see
You see
your
my
monitor. Okay.
screen? Okay.
Yeah,
Thank
yeah,
you.
yeah. Now we see your screen, so you can share
Okay.
your presentation, and the floor is yours. I have to remember you that you
Is
have
it
15
okay?
minutes for your presentation, and then we have 5 minutes
Okay.
for the questions or remarks.
Question.
Thank you very much.
I'll try to go faster.
Oh,
Hi, everybody. I'm Igor Agbosu from the University of Franche-Comté in France, and this presentation will be in accordance with the following plan. I'll talk about the research objective and the scope of the research. I will talk about some questions to address during that research, and talk about urban resilience overview and the frameworks related to urban resilience. And I will stay a little on the experimental cities and the data samples used to produce this paper. And I will talk about the algorithm we use to compute urban resilience K metrics. And I will conclude through the experimental research. So about the research and its scope, I can say that this presentation related to our paper exposes part of our current research work on modeling and simulation by augmented reality of urban dynamics in a perspective of prospective analysis for decision support. Thus, the focus will be on the resilience computing using 3D machine learning algorithm. We are working on a methodology framework for measuring and forecasting key metrics of urban resilience using 3D algorithm for that. So the part of this presentation is concerning this part of the diagram. So I will talk about data, 3D data collecting, and the framework of processing we use in order to make computation about urban resilience metrics. So this presentation, for the question, we have four important questions that drive this research. The first question is, what are the key metrics of urban resilience that can be measured and forecast using 3D spatiotemporal algorithm for forecasting? The data is also a big question because to validate the algorithm, you have to use some data with accuracy and reliability about the research and the result. The third question is how can 3D spatio-temporal forecasting algorithm can be used to capture the complex spatio-temporal dynamics of urban systems because cities are naturally considered as a complex system. So we have a lot of feedback about phenomenal situation, dimension, and how can we capture all those dimensions inside our model in order to express with accuracy the result about urban resilience metrics. And what methodology can be applied and which size of city can correspond for our work. So to continue in that reflection, I want first of all to clarify a little by an overview what is urban resilience. Semantically, some of the concept of resilience around paper and work invoked a positive outcome or a state of being, while others invoked a negative outcome. But what is important to us is that before the 20th centuries, its main meanings was to rebound. So it's the capacity of a system to refine its first state before a shock or a disaster. So the notion of urban resilience is widely now present in different academic disciplines and also in urban planning. So in recent years, several major frameworks have been developed to guide resilience effort in cities around the world. We have a lot of framework, but for this proposal, I will talk about 5 major frameworks which are very interesting to analyze and to take into account in the process of modeling urban resilience scale metrics. So those frameworks have strengths, but they have also a limit. So I will talk a little about the strengths of those resilience, those frameworks and their limits also. So the main strength of those current urban resilience frameworks is the holistic approach to assessing and enhancing urban resilience. They recognize that urban systems and communities are complex and interconnected, and they emphasize the importance of addressing multiple dimensions of resilience, such as social, economic, environmental factors. Those frameworks also recognize that cities face different types of shock and stress, including climate change, natural disasters, economic downturns, and they provide guidance on how to address these challenges. But they have also a lackness. They have also lackness, and about those limits, I can point in the paper, we talk about the 6 major limits, but in my presentation, I try to talk about just the 4 limits. The first is the lack of flexibility and adaptiveness. Those frameworks often rely on predefined indicators and dimensions of resilience, which may not reflect the unique characteristics and challenge of each urban area. So each urban areas has its specificities, its characteristic, which have to be taken into account in the modeling processing. This can lead to inflexible approaches to fail to take account for the dynamic and complex nature. The second nature of urban systems and community. Community have a specificities which have to be to take into account. The second limit is the engagement, stakeholder engagement. In the development and implementation of resilience strategies, stakeholder groups such as communities, members, and local organizations must be taken into account, and it must be defined a policy in order to encourage the engagement of stakeholders. Not doing that can limit the effectiveness and sustainability of those strategies, as they may not reflect the needs and the priorities of all stakeholders. To better understand all those limits, sorry, I will go back to talk about the lack of measurement and evaluation too. That is the core of this paper, because resilient framework may not provide clear metrics or benchmark for measuring and evaluating resilience outcome. And that can make it difficult to access some strategies and so on. And they not have an adequate monitoring data systems or data monitoring science. So in this paper, we try to point out those limits and try to conceive an algorithm based on 3D urban 3D data and urban social and economic data in order to make the computation of urban resilience metric. So here I'll try to explain our proposal framework, a modeling approach. So to better understand the behavior of urban systems in the face of disruptive events, it's important to formalize the dynamics of this system and develop models that can capture their behavior over time. The formalization of urban system dynamics involves the identification of key components and process within urban system and the development of mathematical model that can describe the behavior of this component and process over time. So here, the starting point of the system's usual state is represented by initial horizontal line. That is the anticipation state. And when a disruptive event occurs, marked by stars here, the system performance quickly drops as it absorbs the shock. That is here. And then, once the threat has passed, the system enters recovery phase. That is the recovery phase here. And an event is composed of three elements in summation: magnitude of the shock, the duration of the shock, and the location. That is the spatial aspect of the shock. So the level of resilience recovered by the system depends on various factors. Limited resources may impede the system from fully regaining its original functionality, while ample research and wise application of lessons learned may enable the system to attain a greater level of performance. Effective system management should aim to flatten out the entire curve, including a vector like AB, vector AB, vector array to recover, AB for absorb, array for recover, and adapt, AD for adapt, to eliminate the distribution basin during the period. So to formalize those dynamics, we formalize a master equation with the two equations. So here, the experimental city we choose is Lyon. Lyon is a cities, medium cities located in the Auvergne-Rhône-Alpes in France, and has selected as the experimental area for the implementation of our 3D spatio-temporal forecasting model. This city have a population over 5,000 and an area of 47 square kilometers. The implementation of the algorithm provide a valuable opportunity to test and refine the algorithm in a real-world urban environment. So we use some dataset, cityscapes dataset. We use OpenStreetMap dataset. We use a city JSON, 3D city JSON of representation of Lyon city, and some LIDAR data.
Dr. Agbosu, sorry to interrupt, but I have to ask you to conclude your presentation in 2 minutes time. So if you
2
can,
minutes, okay. Thank you very much.
Thank you very much.
I will try to take it to respect the time. After using that data, let us to process our algorithm, so we can have some result. We test 3 major metrics. We test metrics about traffic congestion. We test a metric about extreme weather and infrastructure failure. So to do that, we compare our result with other region-wise spatio-temporal forecasting model, and we try to evaluate our metrics through 3 evaluation. We use the mean absolute percentage error, and mean average error, and root mean square error. So what we find as a result is that comparing with a traditional method, we note that our algorithm, which is in red on the screen, have a better accuracy, and the comparison with the comparison of different spatio-temporal forecasting metrics using evaluation metrics is an historical average XJ boost, and the conclusion of our work is that we have opportunity to take into account the spatial correlation in our model. That is why we have result about those accuracy. So you have the last line which expose the improvement result. So to conclude, I can say that our future research will incorporate more refined spatio-temporal learning and fusion operators in the research space of the framework, and incorporate additional exogenous information to further improve prediction accuracy. So we are in a work progress processing. Thank you very much.
Thank you very much, Dr. Agbosu, for your very interesting presentation. I'm so sorry for having rushed you before, but we have to stay within the scheduled time. So thank you again for your comprehension. And thank you again and congratulations on your presentation. Are there any questions from the room? Any final remarks? Okay, so we can move on, and the next presentation is entitled Thematic Modeling of Professional Communication Practices of Helping Specialists. The authors are Boris Metriza, Anna Uglova, and Irina Bogdanovskaya. I hope that the pronunciation was correct. Is there, I can see Dr.
Yes.
Uglova
Yes,
with us
hello.
in the rooms. Okay, are you going to present this article?
Yes, just give me a second. I will.
Yes, of course. Yes, of course.
Can you see my presentation?
Yeah, we can see it.
Yes.
We
Great.
can hear you. So the floor is yours.
If you have a PDF.
Thank you. So the relevance of the study of communication practices in a virtual environment is associated with the need to organize a successful dialogue between specialized and clients. The search for a helping specialized requires a high informational and psychological culture from the user. The client's choice is determined by the information that the assisting specialist presents on the web and popular information trends that are created by the digital professional community. The success of the interaction will depend on how well the user will understand the communication strategies and tactics for specialists. In our study, we define professional communication practices as a complex, multi-dimensional processes of establishing and developing contexts generated by the needs of people's joint life activity in a virtual environment. Communication practices in a virtual environment include communication actors as well as technical objects and social culture artifacts like computer intelligent aggregates, content, and like other, are associated with the search of and exchange of information, ensuring the social community of communications while preserving the individuality, function in accordance with the rules of a particular network community, and are mediated by a number of principles of digital media: virtuality, textual character, interactivity, hypertextuality, uncertainty of spatial and temporal localization, creativity. At the same time, communication practices in the virtual space include such characteristics of digital media as programmability, automation, variability, hypermedia, text elements in hypertext, scalability, periodic updating, and transcoding. An additional aspect of the relevance of the study of communication practices in a virtual space is their openness and accessibility for observation. These features allow us to consider communicative practices in a virtual space, including as a methodological basis for studying social phenomena and processes. In connection with the above, we would like to present second research question. What is the specificity of the connect and structure of professional communication practices on helping specialized in digital professional communities? And what methods of psychological influence are used to manage interaction with the audience? The choice to study the B17 platform was Science Now. It is one of the oldest and most popular social network that allows users to communicate with other users on the topic of psychology. We studied only the open part, the profiles of specialized, that is, only the information that users themselves openly publish and themselves. The parsing method was used to collect the data. It was decided to use data parsing methods using a crawler. The crawler is used to automate the extraction of information from websites, which speeds up and simplifies the processing of a large amount of data. However, it should be remembered that the use of crawlers may violate the rules of use of sites, depending on the specific case. Therefore, to use a crawler, it is necessary to comply with the rules of a particular website and legislation. We have studied the terms of use of these websites and found no contradictions. It is also worth noting that we used allow the collect data only for scientific research. We do not use this data for commercial purpose. All the collect data were additionally depersonalized. For this task, we conduct the personalization stage of the data. The personalization is the process of deleting or replacing personal data that can identify and individual to protect privacy and confidentiality. The personalization producer allows you to hide or replace sensitive information while preserving the value of the data for analyze and other purposes. The result of data collection was the MySQL database. The following parameters are stored in database, like specialty, city, number of publications, number of reviews, number of explains of consultations, number of trainings, number of online consultations, full text description for the specialized. The final database contains 2,224 records. In our work, we have carried out intelligent data processing for the descriptions of psychologists that are published in profiles. To solve this problem, we conduct the thematic modeling based on full text description of specialized. Orange text meaning software was selected for data processing. It is a free Python tool used to analyze text data. It provides a set of tools that facilitate the analysis of a large volume of text data, include text classification, clustering, visualization, keyword extraction, and others. In our work, we use the following tools for text processing: preliminarily preparing of the text, building a keyword cloud, thematic modeling. Thematic modeling defines abstract topics in the corpus based on groups of words found in each document and their corresponding frequency. A document usually contains several topics in different proportions, so the widget also reports the weight of topics for each document. Among the methods of thematic modeling, may research still use LDA, a generative model that observes the frequency of words in the corpus and iteratively builds a thematic model for a given number of topics. We settled on the LDA method because in our context it showed the optimal results. The result of processing were 10 topics description by keywords, as well as possibility of visualization. Our results. At the first stage, we conducted a semantic analysis of the uploaded information and identified 55 in unique terms description the connect of the professional source of helping specialists. As a result of the analysis, the basis areas of work were identified: psychological approach, gestalt therapy, cognitive behavior therapy, as well as the most popular methods of work is positivity psychologist, healing family constellation, art therapy, and AST, essence and community therapy. The communication strategy also provides a description of the main object of the work, the image of psychology request. The request to a psychologist is primarily related to the problems faced by clients. A place is given to the description of the idealized image of the result, like happiness and success. The desired result is described quite abstractly, which on the one hand makes it possible to attract more customers, and on the other hand creates confliction exchanges in relevant to specialized. The description of specialized presents psychological transformation techniques for achieve results, which are designed to help change behavior, thinking, or emotional state, active personal growth, as well as overcome various problems and conflicts. The greatest emphasis is on the techniques of taking responsibility therapy, which is associated with the leading areas of therapy. Suggestive intentional statements are also activity used. I can, I want, I do, I find, I know, I try, according to activity actions of clients. The target audience that expects plan to interest is described rather sparingly. There is a separate emphasis on work with children. Adults are not described in a different way, messaged and shared without personal addressing, which reduces the effectiveness of communication. At the second stage, using thematic modeling, we evaluated the structure of the community strategy of helping specialized. As a result of the analysis, the following characteristics of professional communicated on digital platforms can be described. Target opens, which is characterized by the advance of a clearly defined audience and focus on the description of the problem filed. Gender diffuses, idealization of the image of the result of the work, forming realistic expectations of the audience, and the use of suggestion statements. The leading characteristics of professional psychology discourse indicated the integration of its type as professional practices and advertising commercial, which correlates with the main objects of such platforms, but may conduct the ethical principles of helping specialized, which needs further study. At the same time, the communication stages of specialized in the professional community and mediated by such a characteristic of digital media as the ability to work with individual elements of a web page. The use of links, standardization of many functions are elements of communication, hypermedia, periodic updata, and like other. Yes. Based on the results of the analysis, it can be said that the digital platform you under study is focused on the presentation of the following elements of the communication strategy. Analysis of the goals and objects of psychological assistance, though an active description of the issue, self-presentation of professional activities, achievements, and skills of specialized. There is a specificity of the content and structure of professional communicative practices of helping specialized in digital professional communities. The community of helping specialized has both the basic propositive of virtual communities associated with hypertext, target opens, crowd sorting, and absence of geographical boundaries. The virtual community has retained its offline functions, the possibility of self-presentation, exchange of professional information, and like other. The virtual community has created new prospects of the professional environment of psychologists, genre diffuses, changing these ethical norms of self-presentation of serves, expanding the space of communication with patients, creating new conditions for seeking psychologist help. It has also become possibility to evaluate the communicative strategy of using digital resources. The presence of professional vocabulary, basic terminologically, description of transformational techniques, the presence of a product image, an image of result, a description of the target audience, the presence of suggested manipulative technologies. With the help of thematic modeling, it is possible to evaluate not only the work of individual specialists, but also to monitor the professional digital community, the capabilities of the platform for the implementation of all elements of the communicative strategy. Thank you.
Thank you for your presentation and congratulations on your studies. Thank you also for having been within the scheduled time. Are there any questions or final remarks from the audience, from the participants in the room? Okay, so I think we can move on. Thank you again, Dr. Uglova. And the next presentation, sorry, the next presentation, can you hear me?
Yes.
Okay, sorry, I had a sort of an issue. So the next presentation is entitled Forecasting in Shipments, Comparison of Machine Learning Regression Algorithm on Industrial Applications for Supply Chain. The authors are Nunzio Carissimo, Raffaele D'Ambrosio, Milena Guzzo, Sabino Labarile, and Carmela Scalone. So yes, I can see Carmen Scalone here, yes, connected. If you want to share your presentation.
Yeah. Just a moment.
Yes. The floor is yours. Yeah, we can see your presentation now.
Can you see it?
Yes, we can see it.
Okay, so thank you very much for the introduction, and let me just let me a bit contextualize this presentation. So this work is part of my project. I am a PON researcher. So my research project is based on essentially numerical analysis and scientific computing for essentially for the dynamics, for supply chain dynamics. And essentially, my project is also in collaboration with an industry. This is the reason why my co-workers, Carissimo, Labarile, and Guzzo, are from the industry, Code Architects, and also this work is in collaboration with Professor Raffaele D'Ambrosio on the University of L'Aquila. So this is my project, and also this work is involved in an industrial project, which is from this industry, which is the Code Architects, and this project is called Orfeo. So this is so this kind of research is not a standard academic research, but is an example of industrial research. So we have a specific problem, and we try to solve it with advanced tools. This is the reason why researchers like me are involved in the project. So let me introduce a bit the problem. So essentially the idea is to study. We are in the environment of the supply chain analysis. A supply chain is everything we can consider, any step, any detail, the entire system of producing and delivering a product or a service. So from the very starting stage, so sourcing the raw materials, to essentially the final product and delivery to the customer. So all the possible essentially path from the raw materials to the customer. So this is essentially the idea of the supply chain. Our problem is is related to the food industry. And essentially, we will focus just on the final part. I mean, we are in, so the final product is done, essentially, is completely done. And we will work on the part of the delivery of the final product to essentially to the customer, to the end user. I'm very new of the topic, but essentially, what I understood from the literature about this topic is that essentially we should consider the whole essentially supply chain in general if we want to study something about this product, this process. But this is in principle. In general, it is very difficult to take information involving all the network of the supply chain for several reasons. Because sometimes because in general it is very difficult that all the parts of the supply chain communicate each other. So we will just consider the final part. The product is done, so the delivery process. And essentially we are interested into two the problem is the following. Are we able essentially in forecasting, doing a prevision about two variables, delays in shipments and ordered quantity of the product? And as you can imagine, this is very important because we work in the food industry. So the idea is that delay and a wrong quantity produced may cause essentially unnecessary waste, first of all. So from an economic point of view, this is not very good. And also from a green point of view, because a waste is not, if it is unnecessary, we have to try to avoid it. And also, first of all, the satisfaction of the customers. Delay is not so nice when there is a delivery. So this is more or less the idea. The idea is to try to forecast these two variables in the delivery process. And let's see what is our starting point. We have a data set. So this very big matrix of our industry, in which we have essentially any row of this matrix is referred to a particular shipment. Okay, so any row represents a shipment, and we have essentially the data corresponding to the data that you can see in this slide, essentially the customer ID to identify essentially the customer, and the customer zip code to take into account the position, the geographical position, the distance of the customer. About the product, we have an identificative code, the product quantity ordered in terms of units, the product price, and the net benefit per order, take into account sometimes sales, discount, and something like this. A binary variable indicating the late risk, scheduled and real days for shipment. This is our data set, our very big matrix. Any row represents a shipment, and in the columns we have the label, essentially the features of any shipment. So this is the data, and the idea is to try to use machine learning algorithms to try to give an answer to our problem, trying to forecast, to prevent this kind of variables. So, and the idea is to use machine learning because the idea behind essentially this very big word of machine learning is to learn complex relationship among data when we just have the data. We have a large volume, so this problem is a good candidate to be solved via this kind of algorithms. So, but machine learning is a very big word. So essentially, we have to select in some way what kind of algorithm is suited for our problem. First of all, we consider supervised learning algorithms because essentially we have a labeled dataset, and the idea is to train our algorithms in order to classify data or essentially predict something related to data. And in this case, we have two very important, very big classes of algorithms, classification algorithms and regression. With classification, essentially, we categorize data into some groups, some classes, essentially. In regression, the idea is to find we can say a functional relationship between dependent and independent variables. So in this case, we will focus on regression algorithm, but let me say that also working with classification may be possible, because for instance, if when we study the data set, for instance, available, we can say that the day of delay range between 1 and 5. So the idea may be also we can also think to classify essentially the shipment depending on the day of delay, for instance. It is another possibility, but in general, in this work, we will use regression. So how to, essentially the idea is to working with the Python library scikit-learn. Essentially the idea is to work and find an answer with several, in particular three, we will work with 3 algorithms and find the more suited for our problem. We used super vector regression with linear kernel because in general, I have a mathematics formation, so the idea is that it is also useful, first of all, to try with some linear model to understand if the linear model is suited, but we will see that this possibility is not so good. And also other 2 possibilities performing very well are gradient boosting regression and random forest. With gradient boosting, essentially, I just gave you a bit the idea of the 2 algorithms because these are the most important. They work very well on our problem. Essentially, the idea is to so we have the combination of simple models, the so-called weak learners, and essentially the idea is to work with the gradient descent, able to minimize a loss function. And essentially we have the a loss function, and we have the idea is to find the function f that maps x, the independent variables, into y, which is the dependent. In our case, the dependent variables will be the real shipments days and the quantities of product. So this is a possibility, and then we have the random forest algorithm, which is based on essentially minimize the expected value of the loss function. let me just say that in general, the loss function is maybe, for instance, the least square distance between the independent and the f of x. And in this case, essentially, we have again these base learners. And the idea is to essentially, at the end, essentially the answer of the problem, the functional relationship is given essentially considering the mean between the base learners. These are, in general, the idea of the two main algorithms we use it. And okay, we have to, before work on this, work on the data set, we have to prepare it in some way. And so we normalize essentially the data with the min-max scalar function. And we have to split the data set, okay? Because we have, as we usually do with machine learning algorithms, we have a training set and a data set. The training set is we use as usually people do in the literature, people from machine learning do in the literature, the 80% of the data set, and the training set is used by the algorithms to train and to find essentially the functional relationship within data. And then the remaining, the 20%, is the test set, and this is used to validate to validate the prediction, essentially the functional relationship, because at the end of the story, we will focus. So we will estimate the error between the predicted variables and the actual variables of the data set. In this way, we can estimate the error and understand if our algorithms gave us a good answer or not. So this is how we split the data set, and the evaluation of the performance, as I anticipate, we essentially will compare the performance of the algorithms working with the estimated values prediction on the data set and the actual value. Essentially, we will measure the mean square error, the classical mean square error, the mean absolute error, and we will show also the very famous R2 in this is the coefficient of determination very used in machine learning techniques. It ranges between 0 and 1, is in some way essentially when we are close to 0, the algorithm works very bad on our problem. When we are close to 1, we have a very good performance. So let's see the results. We can see that essentially random forest. This is essentially this table represents the experimental results on forecasting the demand of quantities. So random forest and gradient boosting works very well, but random forest a bit better. If you have a look to R2, we see that the values are very close to 1. In this case, supervector regression with linear kernel is a completely wrong model. So essentially, it is not suited for this kind of problem. In forecasting, we say delay, but in general are the real days for shipment. Essentially, we can see that in this case, the supervector regression is not so wrong. Essentially, we are essentially is 0.61, but the performance is not so good as random forest and gradient boosting. Random forest is 0.8, a bit lower with respect to the previous situation, but anyway, essentially good performance. It is fine. So this kind of problem is important because this forecasting is a support also, essentially also to try to work with to try to optimize the supply chain. This is so we can consider these forecasting algorithms to prevent and then use these forecasting for optimize the supply chain. And also this is just to present also other more academic problems. For instance, these dynamics of supply chain may be also studied, described by a system of oscillators, for instance, Van der Pol oscillators, in which possibly we can consider some noise to understand how some metrics are affected by the noise. And also, for instance, they are involved also in the so-called input-output tables, very used in economic sciences. And in this case, for instance, from the numerical analysis, scientific computing point of view, we can construct a suited graph. And essentially, we can work with, for instance, partitioning graph algorithms to find interesting informations from performances from green point of view. This is more related to the environmental things. So this is just to say something more about this work.
Sorry to interrupt you. I have to ask you to go to the conclusion.
Yeah. And thank you very much for the attention. We finished.
Okay, thank you for your presentation, and again, congratulations on your presentation, on your article. Are there any observations, any questions from the room? Okay, so thank you again, and I guess we can move on with the last presentation of this session. Which is entitled An Unseen Features and Enriched Lifelong Machine Learning Framework. The authors are Nazar Ahmad Wazi and Mohammad Abulaish. And I can see Dr. Wazi. Am I correct? The pronunciation is good?
Yes. Thank you.
Okay, thank you very much. The floor is yours. If you want to share your presentation with us.
Yeah, just give me a second. I will.
Yeah, of course.
So, is the screen available?
Yes, we can see it. Okay, perfect.
Okay, so my name is Nazar Ahmad Wasi. I'm a PhD student at South Asian University. I will be presenting my work titled Unseen Features in Enriched Lifelong Machine Learning Framework. Data diversity is essential to generalize an unseen data in data sample using machine learning model. Data diversity basically enables the machine learning model to learn an accurate representation of the given task. Lifelong machine learning is a process of continuous learning that retain knowledge acquired from previous learning tasks and use that knowledge to learn incoming tasks. LML has a knowledge base that include features that the model may not have seen for the current task, but there is a high likelihood that these features have appeared in previous tasks. Therefore, knowledge from the knowledge base is utilized to handle the unseen features. However, there may be unseen features that neither the model nor the knowledge base has covered. Such features are typically discarded during pre-processing phase of the testing data sample. Because unseen features lack associated knowledge, it is basically seen for the first time. It is difficult to incorporate them during classification. In this paper, we propose an unseen features enriched lifelong machine learning framework. in which we, in order to handle unseen features using relative knowledge. So we propose basically two methods to handle unseen features using relative knowledge, a synonym-based approach and a language model-based approach. We propose a LLM framework in which unseen features that appear for the first time during the testing phase are utilized. So an approach is called an LML approach if it is able to continuously learn, store, and extract new knowledge from the task it faces. So as we can see, this is the overall workflow of the proposed approach. When a task DN is assigned with data DN, basically knowledge-based learner is trained on the data for data DN for the task DN, and it uses the knowledge which has been in knowledge base as past knowledge, and then a classifier is produced and classifier is deployed in application area. In lifelong machine learning, if a model is faced with new problems, these tasks can be assigned as new tasks for future learning. And also, during application area, it may face some unseen features for the first time. So in our proposed approach, those unseen features are first looked in language model, and then unseen features are looked in knowledge base, and those features found in knowledge base are incorporated in classifiers. So in this paper, we extend the approach proposed by one more thing. Basically, every lifelong machine learning approach has this task manager, knowledge-based learner, and knowledge base plus this application here. These are four main component of the lifelong machine learning approaches. So in this paper, we extend the proposed approach by 4 to the ULML framework, which is unseen features enriched lifelong machine learning framework. And in this approach, naive Bayes is extended to the lifelong machine learning setting. Basically, we predict the probability of document D given the class CK. Each document D can be represented using a set of features F1 to Fn. In order to get the probability of a feature F, given it is positive or negative, we use the equation 2. And equation 2 FCK is the frequency of features if I appear in class CK. The main parameter of naive Bayes is FCK, comma F. Lambda is a smoothing parameter to avoid the zero division problem, and LB, this symbol denotes the number of features present in the vocabulary. So equation 3 presents the main naive Bayes equation in order for correct classification. For correct classification of document D to the positive class, the probability need to be 1, and for the negative class, it need to be 0 for a binary classification problem. So in order to solve equation 3, we use equation 4. We basically maximize the difference between positive class and negative class for the given document. If the probability of positive is if it's maximum, then it will be assigned as positive class. If the negative class probability is maximum, then it will be assigned as negative class. Basically, and then we use a stochastic gradient descent for this task. So during the testing phase, when document DP, which consists of feature F1, F2, F3 up to FDP, DP is the length of the document DP, is fit to classifier to predict its class label. There might be some features which the model may, which have not seen before. Such features are denoted as FU. And equation, and we formally denoted this concept using equation 7. In equation 7, KB is denote the feature space of knowledge base, and FU denotes the unseen features. FU are those features that the model have not seen before, and it is detected for the first time. In order to utilize such features, we use language model. Language model can be basically instrumental language models such as Waterway, Club, BERT, FastTest, Ilmo, XLNet, GPT. Such kind of language model can be instrumental. So language model is used to extract relative knowledge of unseen features as a language model or vector spaced representation of word that preserve context and semantics. To extract relative knowledge associated with the feature as unseen features, we extract semantically similar features, and then semantically similar features are looked in the knowledge base, and those features that are seen that are present in knowledge base are assigned as relative. The weight associated to those features are assigned as related knowledge. It can be formally denoted by equation 8. Algorithm 1 presents the procedure of UML to handle the unseen features. Again, we can see that if I belongs to knowledge, if feature fi belongs to in the knowledge base feature space, then we use the train model component. If it is not, then we use the equation 8 to calculate associated frequencies. And for our experiment, we use the same data set as our baseline, our base paper have used. In this data set, it contains reviews from 20 different type of products, which is extracted from Amazon.com. This data set has 1,000 reviews for each type of product. Each review presented in data set is labeled as positive, negative, neutral. Those reviews that are that rating greater than 3 are labeled as positive. Those labeled as less than 3 are labeled as negative, and those with exactly 3 rating are labeled as neutral. And because we deal with binary classification problem, therefore we discard the review belong to neutral reviews. So the complete statistics of the data set is presented in table 1. As per table 1, the data set skews toward positive class. Therefore, the minority class is the negative class, which is very hard to classify. In each domain, we randomly partition data into train and test partitions, and the ratio of both train and test in each domain is 80 to 20 respectively. We have used the 5-fold cross-validation strategy for performance evaluations. So this is the data statistics of the data set. We have used the default parameter for all baseline, or as specified in the original paper for our baselines. In order to extract later knowledge in ULMLG, we have used the pre-trained GLAF language model. We extract the top 35 similar features from the language model. And in ULMLS, we have used the synonyms of the unseen features. To extract synonyms, we have used the group doc search synonym dictionary of the Google. Further, knowledge associated with those synonyms that appear in the knowledge base is incorporated as relative knowledge. So in order to evaluate the performance of the proposed approach, we compare it with 3 variants of naive Bayes and 1 state-of-the-art approach, which is lifelong learning for sentiment classification. While performing experiment, each domain is considered as target domain, while the rest 19 domains are considered as non-target domains. And as we know that naive Bayes is a classification approach that works on a single domain. At once, it is fit with 3 types of data to have a fair comparison: NBS, NBT, and NBST. NBS is trained using data from non-target domain. NBT is traditional supervised learning model, and NBST is trained using data from both target and non-target domains. All the above approaches are tested using data from the target domain. LSC is the state-of-the-art approach that use as our primary baseline. NBT do not use data from other tasks, therefore it can be regarded as non-lifelong machine learning approach, while the NBS and NBST incorporate data from other domains. So therefore we can say that these approaches can be regarded as basic lifelong machine learning approaches. So as we can see from the results, that simply incorporating data is an advantageous task. We can see from NBST. And from table 2, it can also be seen that NBS and NBT are inferior to non-NB, which is naive Bayes. However, NBST is inferior to our proposed approach, both proposed approach ULMLS and ULMLG. And so in both proposed approaches, when we use related knowledge associated to unseen features from GLAF, it performed better compared to the synonym-based approach. As these features, so the limitation of the proposed approach can be summed up as as follow. As these features emerge for the first time, the lack of accurate knowledge can hinder the prediction. Suppose there are, which can be seen in ULMLS, because some features there were few synonyms for some features. Therefore, it accuracy has been reduced. Suppose there are so the another limitation of the proposed approach is that suppose if a feature is not present in language model, we assign it as 0, so that cannot be incorporated. And this problem basically this is an out of vocabulary problem. So addressing such problem is out of scope for the current for the proposed approach. So in order to conclude my presentation, in this paper we propose a framework for LML that incorporate features that emerge for the first time when a machine learning model is deployed. First, unseen features are identified by comparing the feature space of the incoming document to the feature space of tasks contained within the knowledge base. We propose two approaches, ULMLS and ULMLG. To handle unseen features, we conducted extensive experiments on the Amazon review dataset. We compared the performance of the proposed method to the tree baseline and one state-of-the-art method. The performance evaluation results indicate the proposed method outperformed the tree baseline methods and is competitive with the state-of-the-art methods. Thank you.
Thank you for your presentation, Dr. Wazi. And I want to congratulate all the participants on the contribution represented by your articles. And if there are no any final remarks or any questions from the virtual room, I would close here this session. Are there any questions? Okay, so again, thank you for your contribution to this ICCSA conference, and again, congratulations on your studies, on your articles, and I hope to see you soon in other sessions of this conference. Again, thank you very much and have a nice day.
हाँ अवनीश ने बोला मेरा अभी प्रेजेंट है, आपको कोई प्रॉब्लम नहीं है डिस्प्ले ग्रीस वाला ईयरली वाला ना ईयरली सेम है नहीं कॉन्फ्रेंस प्रेजेंट अच्छा कॉन्फ्रेंस पेपर वाला कब करा था ये तो 4-5 साल कहां की है ग्रीस ऑनलाइन ही कराओ यार सर आपकी कॉन्फ्रेंस भी हो गई सर क्या करे तो करना तो पड़ेगा ना कुछ ना कुछ तो हाँ बहुत पहले डाला था
the slow nodes. And in this case, the setup before was the setup in the setup before all the times it was getting the best time from the three nodes to get the consensus. This is a resume from the graphic. Setup 1 was the best in average. They created 47 electronic health records, and the setup 3 was the worst scenario. In the average, 41 electronic health records was created per minute. So I can say that the jitter and the latency didn't influence the timing of consensus, the time to create the electronic health records, but the algorithm that makes the consensus influenced a lot the consensus and the size of the blocks also. So the conclusion is that our solution architecture is a promising solution to be used in many healthcare and research contexts. Well, with our solution, we are saving the records there, and the labs can access considering the patient's security. So we are bringing benefits to patients. For example, not just the security, but the historical medical also, and for the health institutions, and we have some health institutions that are partner of our project, and the research lab are from the university. They can benefit from all features like scalability, performance, security, and easy information access. But however, we have some challenges yet. For example, the legislation. So, and the legislations change from one country for other country, and we have some problem related also with the usability of our web application. But we are improving the solution. That's all. Thank you for the presentation.
Thank you, Marcelo. Wow, beautiful photo.
Sorry. Yeah. my wife and my daughter.
Yeah. Do you have any question? Okay, we can continue. Fabrizio Breve.
Hello.
Hi. You can share your screen.
Sure.
Thank you.
Good morning. So I am Fabrizio Brevi, and this paper is Convolutional Neural Networks and Ensembles for Visually Impaired Age. So I'll start with the motivation. Approximately 2.2 billion people suffer from some kind of visual impairment. This is World Health Organization data. And this includes at least 1 billion with some moderate or severe distance vision impairment. And this, the prevalence of distance vision impairment is higher in low and middle income areas when compared to high income regions. So this is a problem that happens mostly on poor countries and regions. This population, the vision impaired, they face numerous difficulties in their daily lives, mostly related to mobility and to navigation. There are advances in computer vision and other technology, related technology, and many navigation systems have been proposed, but most of them, they require some costly bulk equipment, heavy equipment. Some of them you have to carry a backpack with a laptop, and they are not portable, they are not easy to carry around, they are not cheap, they are expensive. Sometimes they require expensive equipment like cameras and other stuff. So, and some of them require connection to a more powerful remote server, so they need internet connection, which isn't available everywhere. So, white canes are still the most used tool to assist visually impaired people. White canes and dogs, guide dogs. White canes are portable, they are easy to carry around, so this is they're cheap. So this is probably the reason it's the most used tool. Some recent surveys show that the smartphone-based computer vision tools for visually impaired people, they often employed some outdated image and video processing techniques, old techniques that are no longer the state of the art. And research have started to adopt deep learning technologies, but since deep learning is usually computer intensive, they are using these heavy equipment that make this unpractical for the users. So the goal of this project is to build a system to assist visually impaired people that execute on a single smartphone. No extra requirements, no accessories, no cameras, no sensors, just the smartphone with a camera, which is cheap nowadays and easy to carry around. It has the requirements to become a widely used tool. So the method we intend to use is the smartphone will take pictures of the path periodically, like 1 per second or more, and provide audio or vibration feedback to the user through the smartphone. So the person would carry the phone attached to the chest height, and it will take pictures of the path some meters ahead of the person, beyond the reach of the white cane. So it can be used together with the white cane. It will warn the user if there is some obstacle in its way. And this paper goal is to perform the classification step. So I'm using many convolutional neural networks models, and I'm trying all of them to see which of them will perform better in this task. So the goal here is to find the best CNN architecture for this task and find the optimal learning hyperparameters. In a prior study, we already built a framework that leverages CNNs, transfer learning, and semi-supervised learning. The focus there was to minimize the computational costs and make it feasible to implement on smartphones without requiring additional hardware. In this study, I'm extending that prior study to add more CNN models, especially the efficient net architecture, which is more recent and wasn't evaluated in the previous model. So 25 models in total. The cross-validation process repeated 5 times to get more robust results. Some image preprocessing functions to enhance the image preparation for the network type according to the network type, and also ensembles of CNNs to boost the overall accuracy. The data set. The data set is composed by 342 images. We build this data set for the previous work. Two classes, the class clear path, no obstacle, and non-clear path, something on the way, some obstacle in the way of the user. This data set, besides it's not too large, but it includes indoor and outdoor situations, different types of floor, dry floor, wet floor, different amounts of light, daylight, artificial light, and different kinds of obstacle like stairs, trees, holes, animals, things that will probably be obstacles for the user at some time. So here are some examples of the images. Here is clear path, and here is non-clear path, something on the way, like stairs, traffic cones, um, and a dog, something that can be on the way when the user is walking. Here are the evaluated CNN architectures, 25 of them, with the input resolution. So the picture taken by the smartphone will be resized to this resolution to be applied to the network. This is the output of the last convolutional layer of the network. And here's the amount of trainable parameters. So we have MobileNet V2 here is the one with less parameters, and EfficientNet V7, the one with the most parameters. Here's how the proposed CNN networks are used. So we have the original CNN here, and its output is fed to average global pooling, then a dense layer, and then another dense layer with softmax to provide a binary output. There is an obstacle, or there isn't an obstacle. The weights are initialized, the convolutional layers with the pre-trained weight from the ImageNet dataset, and the dense layers with the uniform variance scaling initializer. I tested 6 different scenarios, configurations A and B, no fine tuning, and so the networks are used basically as feature extractors. I only train the dense layers. I don't mess with the convolutional layers in these scenarios. 2 optimizers. Configuration C and D. In this case, I'm fine-tuning the weights from ImageNet, transfer learning scenario. The same rate is used for all the layers. It starts with this value and goes with this value and goes with this value, and it's lowered as we are approaching the end of the training. In scenarios E and F, we have fixed the learning rate, a higher rate for the dense layers and a lower rate for the convolutional layers. So we don't mess too much with the pre-trained weights, and we focus on the dense layer until convergence. In all scenarios, up to 50 epochs, with an early stop validation. If validation loss did not decrease in the last 10 epochs, we stopped the training. The software was developed in Python with TensorFlow. The hardware was 3 different desktop computers with NVIDIA GPU boards. That's the reason there is no. I wasn't able to get the time of the training because there are different boards, and this take a lot of time. The training take a lot of time. The inference is fast. So the inference can run on the smartphone, but the training, of course, has to be done on these GPUs. The code is available on GitHub. I use k-fold cross-validation if k equals to 10, 5 repetitions, and 20% of the training instance are used for validation. The batch size is 16, with the exceptions of these methods here, which they are too big to fit these GPUs and still use 16 as the batch size. So I have to lower it so they could run on these GPUs, which have 80 gigabytes of RAM. So here are some results. MobileNet was the best network overall, considering all the configurations, which is interesting because this is a lightweight network. And configuration A, with just a feature structure, no fine tuning, was the best overall considering all the models. That's probably because some models don't train very well. If you try to fine tune them, they get bad results. But the best method overall is EfficientNet before on configuration D with fine tuning, and it achieved this 94 near to 95% of accuracy. Regarding ensembles, so I'm trying to combine several networks outputs to get a better result. So the average sample members for each of the 50 folds. So for each fold, the output of the less dense layer before the softmax is taken, and the probabilities for each class are calculated. The best model for each of the 6 configurations were used, and there are 2 ensembles experiments, one with multiple instances of the same model, just different seeds, initial weights, validation, and so on, and another one with from 1 to 10 instances of the best model on each of those 6 configurations. So here are the results of CNN ensembles with single models. The best results were achieved with 6 instances of the configuration D, EfficientNet before, on that fine-tuned configuration. This got to 96%. Also with 10, but we get the same results with 2 configurations. It's better to use less instance, of course. In all scenarios, there was improvement using ensembles. Configuration D was the best in all scenarios. Using multiple ensembles, multiple CNN models ensembles, in this case, the best configuration was with 3 different kinds of networks. So configurations D, C, and A. These achieved 96%, near to 97%, with 6 instances of each configuration. So 18 networks combined, 6 of each kind. And this led to this result here. So comparing the 25 different CNN architectures to identify obstacles in the path of visually impaired individuals, and I use k-fold cross-validation with k equals to 10 and 5 repetitions to provide robust results. This takes a lot of time, but it's worth it because sometimes the difference between one network and the other is very low, and as they are stochastic, we need to do some repetitions to find more trustable results. The architectures have low computational cost during the inference, so they are able to execute on a smartphone. I didn't implement this on smartphone for this paper, but there are other people in the group that are working on that. and they have some preliminary results that show that it can be done. It can be implemented on a smartphone, on a current smartphone, and fine-tuning the efficient net before achieve the high accuracy of 94%. This was improved to 96% using the 6th instance of the same network, and further increased it to 96 and 96.5% by adding 6 instances of the efficient net B0 and 6 instances of mobile net, which are lightweight networks too. In conclusion, the numerous computer simulations conducted in these studies yield some promising results for some CNN architectures, and investigate the use of different optimizers like Adam and RMS Prof. Different learning strategies like single learning versus different rates, and single learning rate worked better. Convolution and dense layers training, which also worked better. Fixed versus fine-tuned private weights, fine-tuned worked better. And for future work, I intend to expand the proposed dataset, acquiring more images, different scenarios, and exploring other approaches and modifications to the framework to further enhance the classification accuracy. And that's it. Thank you.
Thank you. Do you have any question? Okay, thank you. For me, it's okay. And thank you all.
Thank you, ma'am.
Thank you. Bye. Perché da me lo fai?